Hello and welcome to Chapter 6, Section 3. We're talking about using properties with rational numbers. And we're going to start with the word problem that's on page 240. If you could have your book open, push pause and open up to page 240 so you can read along as we do this problem together so I don't have to write it out. Orlando works part-time at a moving company. He earns $12.75 an hour. He works for 4 hours on Friday and 7 hours on Saturday. Use the distributive property to write equivalent expressions showing two ways to calculate Orlando's total earnings. Now there's two ways you can do this. You can say that he works 4 hours on Friday and he makes $12.75 an hour. Plus he works 7 hours on Saturday and he makes $12.75 an hour. And when you multiply this and add them together, that's his total pay. You could also say that he makes $12.75 an hour and he worked 4 hours on this day plus 7 hours on that day and multiply $12.75 by the answer to this. And what they're looking for is for you to write this equals this. So you're writing two equations that are equivalent expressions. They're equal to each other. But they state it in two different ways, and one of them uses the distributive property because you're going to distribute. You can distribute this or you can just do this multiplication. Does that make sense? We're going to try another one together. Katie earns $14.25 an hour and Joan earns $11.75 an hour. They each work 8 hours. How much do they earn? And the question is, please write this two ways. I would like you to pause here, work this out, and then push play when you're done so you can have some practice and then you can do it with me. So, Katie's going to earn $14.25 an hour and Joan earns $11.75 an hour. We're going to do this two ways. The first way we're going to do it is we're going to say 8 times $14.25. And then we're going to say 8 times $11.75. So we're going to take what Katie earns and add it to what Joan earns. That's one way to write this. The other way to write this is to say 8 times $14.25 plus $11.75 because they want to know how much they earn together. So if you add these two together and then multiply the answer by 8, you're going to get the same answer as this. Try it in your calculator and you'll see that they're the same answer. Okay? This is how you do the homework problems that look like this. They want two different equations that you say are equal to each other. Next, we're going to talk about writing equivalent equations. Equivalent equations means that the equations are equal to it. So, the first thing we're going to do, we're going to be looking at equations with fractions in it, and working equations with fractions can be difficult. So the first thing we're going to do is get rid of the denominators. And the way that we do that is we're going to multiply all the terms by all the denominators. So, let me give you an example. Here we have 1/3 x minus 4 equals 2/5, and we have to solve for x. This is not an easy problem to work. The way to make it easier is to get rid of all the denominators. So we're going to multiply all the terms by all the denominators. Well, all the denominators is 3 and 5. So 3 times 5 is 15. We're going to multiply everything by 15. So what I'm going to do first is I'm going to spread this stuff out so we can see what we're doing. We're going to now when you multiply anything by a fraction, a whole number by a fraction, you're going to make it a fraction. We're going to multiply this by 15 over 1. We're going to multiply this by 15. And we're going to multiply this by 15 over 1. Because these are all the same number. And when we do everything on both sides of the equation by the same thing, we're not changing the equation. We're making equations that are equal to it. These are all equivalent. Now, when I multiply these two together, I can cross cancel my 3. 3 goes into 3 once, 3 goes into 15 5 times. 1 times 5 is 5 over 1. And here's my x. 4 times 15 is 60. And here I'm going to cross cancel my 5s. 5 goes into 5 1 times, 5 goes into 15 3 times. Now my denominator's 0, that's great, or excuse me, 1, and that's great. And now it's gone, and 2 times 3 is 6. And now we have an equation we can solve. 5x minus 60 equals 6. Now, I want to solve for x. We did these, I want to say chapter 2 or 3, so we're going to review that really quick. We're solving for x. It means we have to get x all by itself. There's a 5 multiplied, and there's a 60 subtracted. We've got to do the opposite to get rid of them. And I'm going to start with the farthest one away from the x first. So the first thing I'm going to do is add 60 to both sides of the equation. Now this goes away, and I have 5x here, and I have 66 here. And I'm going to divide each side by 5. Because there's a 5 multiplied to my x, to get rid of it, I'm going to divide each side by 5, so these go away. Now, 5 doesn't go into 66 equally. But I can do a quick long division problem. 5 goes into 6 once, and 5 goes into 16 3 times, 15 with 1 left over, and I'm going to take that 1 and put it on top, and I'm going to take that 5 and put it on the bottom, and now I have 13 and 1/5. I need these answers in fractions, not the decimals you get in your calculator. Now, you want an easy way to do this with a calculator? Do 66 divided by 5, and it will say 13 point a bunch of stuff. So you know it goes in 13 times. And you're going to ignore the decimal point for just a minute. You know there's more. So you have to go in your calculator 5 times 13. And 5 times 13 is 65. How many are left over if you subtract 65 from 66? 1/5. You can do this with a calculator and still get a fraction. Rewind this and watch just this part again so that you can get that, because I'm going to ask you to do this again. I need you to solve this. Write this down, pause the video, and go through all of these steps until you can solve for x. Then turn this back on so you can do it with me so we can catch any mistakes we have. All right, so the first thing we did, our denominator is going to be 12, 3 times 4. So I multiply everything by 12. Here, I'm going to take a 3 out of here and a 3 out of here. I'm going to take a 4 out of here and a 4 out of here. 2 times 4 is 8 with my x. 9 times 12 is 108. And 3 times 3 is 9. Now I've got whole numbers. Now I can solve for x. I'm going to start with this because it's farther away. I'm going to add 108 to both sides. So now 8x equals 117. And I'm going to divide each side by 8. And 8 goes into 117 14 times. 8 times 14 is 112. 117 minus 112 gives me 5/8 left over. You're going to have some problems that look like this. If you still are confused on how to do this, rerun this video from right here and watch it again so it sinks in, okay? Next on page 241, they have another word problem. Maxine is replacing a 14.25 meter row of wood floor. She has already placed a strip that is 0.75 meters long. How many 1.5 meter strips of wood does she need to finish the row? Write and solve an equivalent equation without decimals. First, we're going to write the word problem down. Now, they write it down like this. They say there's a 1.5 meter strips, and they don't know how many it's going to take, and they're going to add that to 0.75, and that's going to equal the 14.25 that they're trying to fill. This is not how I think. If this is how you think, then this is great. When I want to set it up, I'm going to start with the 14.25. I'm going to take away the 0.75 that they've already placed, and I want to see how many 1.5 strips that makes. This makes sense logically to me. I need to show you that these two are the same thing, because here, when they have 1.5x plus 0.75, the first thing they're going to do is get rid of this to get their x. And they're going to say minus 0.75 minus 0.75. And they end up with 1.5x equals, because this goes away, equals 14.25 minus 0.75. Get it? It doesn't matter. Well, it does matter. You have to do it the right way. But you can start your problem the way it logically makes sense to you. You just need to know how to get out of it. Now, they don't want any decimal places in their answer. So what we're going to have to do is multiply everything in the equation by how many places there are. Tenths, hundredths. If we multiply everything by 100, all the decimals go away. Which means we're going to move this decimal place 2 times. 2 times, 2 times. So this becomes 1425. This becomes 75, and this becomes 150x. Because we have to have that placeholder here. Now you can do this subtraction, which will get you to 1350 equals 150x, and you can divide each side by 150 to figure out that x equals 9. We're going to do one more that you're going to do yourself to make sure you know how to do the homework. So I'm reading on page 242, number 9. Nancy places $7.15 in an envelope each week. She currently has $64.25 in it. In how many weeks will she have $121.45 in the envelope? So each week, so we don't know how many weeks, so that's going to be our x. Each week she puts in $7.15. She right now has $64.25 in, so we're going to add that in and to every week. And we have to figure out how long it's going to take before she has $121.45. And we have to do this without decimals. So we're going to multiply everything times 100. Times 100 times 100, because there are 2 decimal places. So now we have 715x plus 64.25 equals 121.45, 12,145. Pause here, solve the rest of this, come back when you're done. So, first thing we're going to do is get rid of this. We're going to say minus 64.25 minus 64.25 and bring down our 715x, and that goes away, and this equals 57.20, and we're going to divide by 715 because there's a 715 multiplied to my x, so now I have to divide by 715 so that these cancel out and x equals, and we do this in our calculator and we get 8 weeks. So your homework tonight starts on page 242. You're going to do numbers 10 through 31.